So in this case, we are going to consider a typical revision, which is as we are revising for our March tests, depending with the school that you are from, we are going to actually have as part of our SBA, remember, as you are revising, these marks, guys, you just need to totalize or just to have all these marks. So this is a term one test that you're going to have, a common test, which was written before in March 2024. So we're going to consider these questions and see. We might have similar questions. So for those maybe that have already written the tests, unfortunately, we are just gonna have these guys for those who have not written. But the importance of these tests, guys, it is not just for you to be saying I'm revising because it's a common test that I'm gonna have in March. No, these tests, they are important even up to your November examinations, because whatever that you have, it is part of your syllabus, part of what you are supposed to be learning at school. So meaning to say you're supposed to take every question seriously. You can have those questions as they are on your final examination. All right. So we're not going to waste much time, guys. Make sure that you read all the instructions. There, you may use an approved scientific calculator that is the non-programmed or non-graphical. We can use those ones that are non-programmed. All right. Follow the numbering system used in this question paper. If necessary, round off to 2 decimal places unless otherwise stated, meaning to say we can be given another instruction, maybe to 1 decimal place or to 3 decimal place, but whenever you're not given any other instruction, meaning to say you're supposed to use 2 decimal places. All right, so like I said, guys, I'm not going to waste much of your time here. We have talked about almost everything in this question paper that we're going to revise. So on question number 1, this is the part of the multiple choice questions. That is the part 1. Choose the letter in them with the correct answer. All right. So choose the letter with the correct answer. Which of the following is a natural number on 1.1? A natural number. When you consider a natural number, remember these are counting numbers where 0 is not included. Remember, when you are just talking about whole numbers, there's a part that you consider to say, all right, they are natural numbers where 0 is not included. So you're talking of what? Counting numbers. Counting numbers. But on these numbers, 0 is not included. 0 not included. We are not supposed to have it. So meaning to say, number C is totally out because we have a 0 there. So this one is totally out. Guys, if you consider pi is not even a counting number. This one is a decimal. All right, we've got a calculator. So you can just use your calculator, guys, to evaluate that shift. You press this, we've got pi. That's equal to, as you can see, guys, as a decimal 3, as a decimal, this one. That's not a counting number. So it's totally out. The square root of this one, we can also use our calculator there to see this one. The square root of 9 over a 3 like this. As we can see, we have square root of 3, which is an irrational number. As a decimal, look, guys, a decimal which does not end. So the correct answer there was B, where we've got 25. That's a counting number, that one, a whole number. 0 is not included. So that is what we're going to have, which is what? Which is B. So you're going to write your answer as B. Then on 1.2, calculate. Guys, this is multiple choice. Use your calculator because it's also part of your learning to use that calculator. All right, just use your calculator there. What are we given? That's 2 plus, all right, we have minus 3. So we open up, this is the minus that we're supposed to use, this one, inside the bracket, the one that we see here, inside the bracket. That is the minus this one that we are talking about, this one. So you're just gonna put a bracket first. So you open a bracket, you've got minus what? Minus 3. It's part of your calculator also to learn, because this is, say, other guys, this is multiple choice. Unless you have it where you're supposed to calculate. Minus 5, all right? Open a bracket there, just evaluate. That was gonna give us what? Minus 6. So minus 6, this is what we have on A. So that was the best answer that we have. Or we can just evaluate 2 plus a minus 3. All right, in case that you are not that someone who is into the calculator, a plus and a minus is going to give us what? A minus. A plus and minus, a minus. So that's it, guys. 2 minus 3, that's a minus 1 minus a 5. So as we have minus, minus, guys, as we have got the same sign in this case. So simply add the numbers, then you use the common sign on your answer. All right, so that is it. We have our answer there as what? -6. On 1.3, simplify this again. If you are in section A, you can just use your calculator. All right, so what are we having there? Open a bracket, minus 8 over what? Over 4. So you close, just move aside, close the bracket to the exponent of 2, that's squared. Or you can have this, then you put a 2, or you can just have a squared like this. Minus, you open a bracket, minus 4 as it is. So that's minus 4 as it is, the way that you see there. Minus the square root of what? The square root of 64. This is part of your calculations, guys. You're going to obtain what? A 0 there. That was the best answer, which we have. Or we can simplify this. Minus 8 over 4. Minus 8 over 4 squared. Minus 4. This is what we are given. Then we've got minus the square root of 64. So take note here. Take note. We can simplify what is inside of the bracket. Remember, your board mass, it still exists. Our board mass, brackets of division, this and that. So we can simplify inside of the bracket. Minus 8 divided by 4. This is what? Minus 2, guys. We can see this one. That's a -2 squared minus, and a minus, that's what? A plus. We can even simplify a minus, minus. That's a plus. So you're going to have 4 minus the square root of 64. It's very true, guys. We are focusing with the brackets, but as we have that square root of 64, we can even evaluate that one. We know the square root of 64. That is what? That is 8. Or you can even use our calculator to simplify that. All right? So minus 2 squared. That's simply minus 2 times minus 2. Negative, negative. That's a positive. So you can simply ignore that one. So 2 times 2, that's a 4 plus a 4 minus 8. So this is what we have. According to our board mass, we can start with addition. So you can add 4 plus 4, which is 8. Then we've got this minus 8 at the end. Remember, we are simplifying this 4 plus 4, which is 8. Then 8 minus 8, that was going to give us what? A 0 there. All right, so as we can see, the same answer, just like the previous case where we just applied or used our calculator at once. All right, let's move on to another part, which is 1.4. Which number is equal to a to the exponent of 0, a to the power of 0? Guys, any number to the power of 0 from our laws of exponents is what? Is 1. So where are we having a 1? That is on C. So this is the best answer that you're going to have, which is C. 1.5, the general term of the sequence 1, 4, 7 is... So if you do not know, guys, you can even try, like, you substitute, like, the first term is when the first term, the way that you're given that it's 1, the second term, you can substitute the value of n to say when n is 1, when n is 2, when n is 3, to see which one is going to give us exactly what is corresponding. You can have that trial and error. All right, this is what I'm trying to say, because already the answers are there. So this is what I'm trying to say. The first term, this is 1, T2, T3, and so on. So you're simply saying when n is 1, this is our first term, which is 1. So if I substitute n, which is 1, in place of n here, I put a 1, I put a 1, I put a 1, I put a 1 like this. Where am I going to have exactly the number that is there on our T1, which is 1? The answer that we have there representing T1 is what? Is 1. So where are we going to have that 1? We can substitute, right? So if we simplify this one, 3 times 1, remember 3n means 3 times. So that's going to be 3 plus 1, which is 5. As we can see, this one is totally wrong because we need a 1. We move on to this one, minus 3 times 1, that's minus 3 plus 2, which is what? Minus 1. We can even use our calculator. As we can see, it is not giving us a 1. So meaning say this is totally wrong. We move on to C. When we substitute a 1, 3 times 1, that's a 3 minus 2, which is what? Which is 1. Exactly the one that we want. So this is correct. So we need this part. We also do the same thing here. We substitute a 1 that was going to give us minus 3 minus 2, which is what? Minus 5. So as we can see, it is different from what we need. We need a positive 1 there, not a negative 5. So this is totally wrong. So guys, this one, it is a trial and error where you're substituting to the answer that you're already given. The answers are already there. You substitute, all right? If you can also do that for the second term. When n is equal to 2 for the second term, if I'm to substitute, I'm supposed to get a 4. So you will see that this one is supposed to give us exactly a 4. Let's substitute in place of n. 3 times, in place of n, we put a 2 minus what? Minus a 2 according to our formula. Remember, this is 3n minus 2. This is our formula. So let's calculate this one. 3 times 2, that's 6 minus 2, which is what? Which is 4. Exactly the number that is there. So this is our general term of the sequence that we are given. All right, guys, make sure that you go through the introductions. I talked about this. All right, anyways, without using these answers, how are we supposed to obtain the general sequence of these? I mean, the general term of this sequence. All right, let's have our sequence aside. I just hope it's going to be clear. So if we consider from the part that I worked on the numeric patterns and the geometric patterns, I say that if you are given a sequence like what we are given here, which is 1, 4, 7. So this is another way using exactly way that you're supposed to work to say, of this sequence that I'm having, do I have a constant difference or a constant ratio? So I say the first thing that is easier to test is what? The constant difference. So start with what? The constant difference. Then you move on. If there is no constant difference, then it means you must get what? A constant ratio. So remember your constant difference simply from the second term minus the first term. Next term minus previous term. Next term minus previous term. So this is the case. Next term minus the previous term. 4 minus 1, which is 3. Next term minus the previous term. 7 minus 4, which is 3. So as we can see, we have what? A constant difference, 3. So if there is a constant difference, I say that your general term is given by what? Tn is equal to the constant difference times n plus what must be added to give us exactly what corresponds on that particular position that you're given. So this part here is what? Your constant difference, this one that you already calculated. So we have this one is what? Is 3. This is our constant difference. But this is what? what must be added to give us what is corresponding. Is it either this one, is it this one, or this one? What is corresponding at that position? What must be added? What must be added to give us the term in position? To give us the term in position. In that position that we are given. So we can simply use the first position. Instead, yes, we can use the second, third, whatever that you want. So on the first position, what does it mean? First, I'm using first, take note, position. So I'm talking about first position. So it means n is equal to 1. First position, n is 1. If I'm talking about second position, n is 2. Third position, n is 3, and so on and so on. So if I'm using the first position, it means n is 1. When n is 1, what is there on our first position? T1 is equal to what? To 1. T1 is equal to 1. So this is what it means. With this expression or the format that we are given, we're going to substitute T1. T1 is what? Is 1. So here, guys, it's just like we are using the same number. 1 is, do not get confused there. This 1 is this one. To say T1 is what? Is 1. All right. Which is equal to what? Which is equal to 3n. Our n is the one that we are talking about to say when n is 1, the position, first position. First position, this one. First position. This is the n that we are talking about. Remember, n is about what? N is about your position. But guys, I talked about this on the introduction. Go through that video. So we're going to substitute a 1, your position. If it is position 2, you substitute 2, but position 2 corresponds to what? To 4. Position 3 to 7. You must substitute the value corresponding to that position. Position 1, the value is what? Is 1. Plus, what must be added to give us the term input? What are we supposed to add? We do not know. So this one, we do not know. What are we supposed to add? So that's 1 is equal to 3 times 1, which is 3 plus what we do not know. So we are supposed to find this. How can we find this? Just take this to the other side. It jumps the equal sign, it changes the sign. 1 minus 3. So it's now minus 2 equal to that part which we said we are supposed to add. So meaning to say the number that we do not know all along that we said we do not know, this one is what? Is minus 2. So there is a minus 2 there. So therefore, we are simply saying our Tn can be written like this, which is what? 3n minus 2. So if we are to consider, is it exactly what we said before? Exactly the answer that we had before, which is on this one. Remember, we said our answer is at what? At C. So you could have applied the actual way. It's up to you. Or you could have just substituted because the answers are already there. The answer is already there. You have to check which one is the exact answer. All right. On another question, we are given, in this case, find the LCM of 36 and 63. So the LCM, guys, is easy. You know, guys, as you are working with the LCM, you are going to need the product of prime factors of whatever that you are given them. That's 36 and what? 63. Let me, okay, this one is too much, guys. Let me just use this side. All right, so that was our question 2.1. So we're given two numbers there, 36 and what? 63. And we need to determine the LCM, the lowest common multiple. Remember, even if it was for the HCM, you were going to express these numbers as a product of their prime factors. As a product of what? Prime factors. As product of prime factors from the ladder diagram, from that ladder diagram concept. So let's start with our 36. What is the smaller number that we're going to use, which is when we are saying, guys, the prime factors, yes, the calculator can do this for you. Because most of you guys will be saying, say that time you could have just used a calculator. Yes, you can do that. How can I use my calculator? 36 is equal to, all right, 36 is equal to, you start with the number, 36 is equal to, then shift fact. So as you can see, it gives you the answer. So you say 36 answer is equal to, that is the answer on your calculator. You press the answer button, then shift fact like this. It's gonna give you as a product of its prime factors. This that is that we need, guys. We already have the answer here. 2 to the exponent of 2 times 3 to the exponent of 2. But let's say I do not want to use the calculator. I want to have the exact way. The smallest prime number is 2, the smallest. Remember, when you're dealing with the prime numbers, exactly divisible by 1 and itself. And 2 is a prime number. It's just 2 and 1. 3, 5, 7, and so on and so on. 11. So these are the prime numbers, exactly divisible by 1 and itself. So start with 2. If 2 is not working, you move on to 3, to 5, and so on. So here 2 can work. 36 divided by 2, that is 18. We try again. Can 2 work? Yes. 18 divided by 2, that's a 9. Can we use a 2? No. If we use a 2 like this, 9 divided by 2, it's going to give us a fraction, a decimal. You're supposed to obtain what? Whole numbers, exact values. So we move on to 3. We try a 3. 9 divided by 3, that's a 3. 3 again. 3 divided by 3, that's a 1. Until you get a 1. Remember, 1 is not a prime number. 1 is not a prime number. So you cannot use a 1, 1, 1, 1, and so on. 1 is not a prime number, guys. Once you get a 1, these are the numbers that represents 36. So we simply say 36 is equal to what? 2 times 2. 2 times 2 means what? 2 to the exponent of 2. 2 to the power of 2. There is a 3 and a 3 again, which simply means what? 3 to the power of 2. 3 is multiplying itself. So that's 3 to the power of 2. So are you seeing, guys, same answer with this one? So we could have just used our calculator to prove that or to verify our calculation. We do the same thing on this number, which is 63. Can we use a 2? No. 63 divided by 2. It's going to give us a decimal. So you test. You move on to 3. 63 divided by 2, that is 21. Again, we use a 3. 21 divided by 3, that's a 7. So we cannot use a 7. We cannot use a 3. We cannot use a 5 because 7 is a prime number, guys. So we're going to use a 7 as it is. 7 divided by 7, that's a 1. Until you get this one. So it means 63 is equal to what? 3 times 3, which is 3 squared. 3 to the power of 2 times 7, which is just appearing as it is once. So you can write as 7 or 7 to the power of 1. You can leave it like that. So that's our 63. So if we are to use our calculator again, we could have verified that 63 is equal to, first thing, then shift fact, 3 to the exponent of 2 times 7, as we can see. So remember, I told you guys, when you are calculating the LCM, we talked about this. No, guys, we talked about this. It's not like we never had a class about this one. We talked about this one. I said, you are going to take every term as long it appears. You must consider 2, is it appearing? You take it. As long you can see it, guys, you must take it. Is the multiple. It consists, multiple is the mother of everything. It takes everything, multiple. It takes everything. So 2 is supposed to be there. So we only see it once here. It is 2 to the exponent. It is only appearing once, so there's no comparison. But if there was a 2 to the exponent of 2, maybe another one has got 2 to the exponent of 5. You're going to take the one with the highest power. But here there's no comparison. It is just the 2 that was here, only one. So we take it as it is, 2 to the exponent of 2 times. We move on to 3. On 3, there is a comparison to be made. There is a 3, there's also a 3. Which one has got the highest power? They have the same power, to the power of 2 to the power of 2. So we are simply going to take as it is, guys. We cannot say this one has got the highest power compared to this one. They have the same power. So you're just going to take one of these. You do not repeat that. All right? 7 is appearing once. Again, just like this one. It was appearing once. Same as the 7. So there's no comparison for that one to say which one is the highest power, both it is appearing once. So you take it as it is. There we had to compare, but as we had to compare, we saw that it is still the same power. So it is like we did not compare, but we had to compare there. Maybe this one was having a 3. We are going to take that one, which is what? The highest power. But anyways, guys, this is it. So we can simplify this. Guys, we're having our calculator. Use it. That's the opportunity, guys, to use your calculator also. They said you can use your calculators in this exam, in this test that you are having. So meaning to say, if you can have your calculators used, guys, use them. So you can have this 2 squared, 2 to the exponent of 2 times 3 squared times what? A 7. So this is going to give us 200 and what? 52. So that's 252 as the LCM. Okay, let me just add another question here, not to say you were being asked. Do not do this in exam. I just want you to understand. Let's say the question was asking us now to determine the the HCF. What was going to happen? The highest common factor. A factor, you are supposed to take all the common part. The common part. All right. It's only that, guys, I do not teach you natural sciences. It's not like I haven't started to teach you that. If I was teaching you that we're gonna express other terms which we have there in our natural sciences there that we can understand, like the one that I was trying to refer here to say this one is the mother. So it consists of all. Right. So this one is gonna difficult for me to explain because you tend me to like I was explaining something else which was not mathematical. And also, no problem, guys. Some of the terms that we use, depending on the subject, with this platform that we are using also to teach you guys, it can also be like we are using other words which are not proper. So anyways, the highest common factor is weird. I just said, let it be a common term. Let it just be common. So you just look, okay, is 2 common? 2 is not common. We just have it here. On this one, there's no 2. Is 7 common? No, we do not have it here. So these 2, they are totally out when you consider the highest common factor. 3 is common, this one. We can see it on both. We can see it, this one. But we're going to compare now to say which one has got the smallest exponent when dealing with the highest common factor. You take the one with what? Smallest exponent, the smallest power. But in our case, we can see that they are just the same. 3 squared, which is what? Which is 9. That was going to be your HCF. So in this case, I'm just saying if the question was going to talk about this, but our question was this one, guys. So do not All right, don't mind me, guys. I just wanted you to learn as you are revising. Don't just revise that question alone. Know what you're gonna have, because they can change and say, find the HCF. Because guys, they know that you are now revising these questions. They know that these days there's YouTube, this and that. So they know that you're gonna be having these questions. So they can just change. So also, as you are revising, understand both things. All right. Anyways, 2.2, the table below shows the number of men painting a house and the time in hours it takes to complete painting. They did not mention anything further special there. So you have to compare when you are relating this type of a question. The number of men they are painting a house. So the house that they are painting becomes constant. We are going to compare according to the house to say there are few men who are painting the house. In terms of the hours that they will take, and there are many men who are there, in terms of the hours they are going to take, how is it going to be? This is a real life situation, guys. There's a house, you have your own house there. You take 2 men to paint the house. Then you take 5 men to paint the house. What is going to happen? You see that 2 men will take more time compared to 5 men. They will take less. When it comes to the time in terms of doing a job or completing a certain task with the number of men or the number of people, that one is an indirect proportion. The lesser the people, the more time they will take to complete the job. The more people that are there, the less time, because guys, you are many. So you complete that task in lesser time. Remember, indirect, what does it mean? This one, when it is more, look at this one, it is less. Does it correspond, guys? No, 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 no. The smaller number was supposed to be less. The bigger number was supposed to be more, so that we say it is a direct proportion. But whenever this occurs, that a smaller number or corresponds to more, a bigger number corresponds to a less or to a lesser. That is an indirect proportion. So I have actually answered question 2.2 to this one. Is the above table an example of direct or indirect? So this one, it is an indirect. When one is increasing, another one is decreasing. A vice versa of how you interpret the actual meaning of the rate of work. Like, okay, we are working with the rate of work, guys. Indirect proportion. Direct, the lesser value must be of a lesser. The bigger value must go to a bigger value. So how do we calculate? Because the question here was to determine the values of A and B. So you know, guys, I talked about this on indirect proportion. When you are already given a table like this, remember that the constant, because we said it's what? Indirect. The constant is equal to the product of the variables. Product. Take note. Product of what? Variables. The product of the variables, to say this is my X, this is my Y. The product of these two must be equal to the product of these two. Must be equal to the product of these two. So with that alone, you can form an equation to solve for A and B. This is it. Just like that. With that, guys, you can form an equation, because you are simply saying the product, these are your variables. You let the number of men be X. the time in hours by y. So variable x and y. So you're saying k is product. You multiply these two, x times y. X times y. 1 times 4 is equal to. When we say it is equal, guys, it means throughout, if I use these two, I must get the same answer if I use these two. So I'm going to use 4 times a. So it must be equal to 4 times a. It's an equation, guys. We have formed an equation like this where we can solve for a. 1 times 4 is what? It's 4, which is equal to 4 times a, which is 4a. So divide by 4. Remember, this is a product. Divide by 4. We are back to our equations. You must know how to solve your equations. So 4 divided by 4, guys, that's what? That's a 1. So a, in this case here, represents a 1. You are going to do the same thing to find the value of b, because that constant, remember I said it is the same throughout. So you can use it again back here. X times y. 1 times what? 1 times 4. So on another part, we are going to use it like that. 1 times 4 must be equal to what this time? You take it here where there is b and what? And 2. So it's b times what? B times 2. You have formed an equation again where you can solve for b. 1 times 4, that's a 4, is equal to b times 2. That's simply 2b. So to find b, this is a product. So divide by what? By 2. So that's what that was going to give us the value of b. 4 divided by 2, which is 2. So that's it. Our value of b here was going to be a 2. So guys, just like that. Just like that. So do as many revisions as you can preparing for your exams. But as for this part, I've referred many examples. Make sure that you go through the introductions. Make sure that you go through those introductions, guys. All right, 2.3. A car is traveling at 100 kilometers per hour. What is that? The speed, kilometers per hour. We are given the speed, 100 kilometers per hour. How long will it take? How long it is the time that we are being asked there. To travel, what are we traveling? To travel 300 kilometers, a distance is traveled. Travel a distance of. So we're given a distance there. So the question is find time. Remember our DST diagram, this triangle, distance, speed, time. Distance is equal to speed times time. What about if we want time? The part that you close, we're going to close here. We want time. So it means time is equal to what? If we close it, distance over speed. You close this one. So you remain with what? Distance over speed. Distance over speed. So it simply means in our calculations, time was going to be calculated as distance over speed. What is our distance? We have it 300. And what is our speed? That is 100. So this is it, guys. We know that if we are given kilometers, this must be kilometers per hour so that our time is in hours. So as we are going to divide, this was going to give us what? 3, which is what? 3 hours, just like that. Just like that. So these are the typical questions that you might be given. All right, 2.4, it was the condition where you're supposed to apply the compound interest. So actually for this one, guys, you're supposed to forgive me because I was actually asked to work out this topic of compound interest. Someone asked me, say, can you do this topic? Guys, I'm going to do that one. But you understand me as I'm doing it now. But I'm gonna do it as a separate topic. I promise you guys, I promise you guys, I'm going to do it. But let's save it now. We are given that Carol invest 18,000. This is the money invested. So the money that is invested is referred to as the principal, which is P. Just like the money which you borrow, the money borrowed, it's represented by the letter P. This one is supposed to know these letters because I talked about this with you guys on simple interest. So these letters, you still have them. They never changed. All right. P is still the P. It's only the formula. So our principal is 18,000. So here I was going to waste much time because I thought I did not explain the simple interest. I talked about simple interest. Also, like I said, everything is going to remain as it is. So you know that number of years is what? It's N. So we are given 6 years at a rate of, this is the difference that you see on your question. The interest that you are given per annum will be compounded now. Annual, like annual is just that per annum. Compounded annual. Compounded. It's no longer simple interest. Remember in our previous question, we're given at a simple interest of, at a 15% simple interest per annum. Simple interest. Now they're saying compound. Once you're given that, guys, you know that you are supposed to use what? The compound interest. So it's 15%, but it's being what? Compounded annually per year. Per year annually. Compounded here. Once you see this, you know that you are dealing with the compound interest where the formula states, all right, I'm going to go back there, but I want you to know the formula, which is P, A is equal to P into 1 plus R over 100 like this to the exponent of N. Like I said, R, as you use it like this, it is given what? As a percentage, this one. As a what? As a percentage. So our question was, what will be the total value, the total of everything, Carol's investment after 6 years? After everything, this is the accumulated amount. They're asking us to calculate the accumulated amount. After what? Any years. After 6 years. Our N is 6. So this was just a mere substitution, guys, direct into the formula. We have got everything, guys. Substitute. P is what? 18,000. So that's 18,000 into 1 plus our R as it is as a percentage. 15 over 100 to the exponent of what? Any, the number of years is 6. So guys, this type of equation, do not try to be a hard person. Use the calculator, all right? Use calculator, and you're dealing with money to 2 decimal places. You round off to 2 decimal places if you're dealing with what? With 2 decimal places. All right, so let's take our calculator. 18,000 like this. We open the bracket. There's a bracket there. 1 plus. You put a fraction, this one. So it's going to be 15 over 100. So that's 15 over 100 like this. Then move this one aside. All right, this arrow, just move it aside. You close the bracket to the exponent of 6. So we need this x to the exponent of, all right? So that's a 6 there is equal to. So this is the answer that you're going to get to 2 decimal places. We can also fix our calculator. Shift, you go to the setup, then fix its number 6. So we're going to press 6 to 2 decimal places. We press 2. So it gives our answer to 2 decimal places, this one. So that is what you're going to get, 41,635.09. So that is our accumulated amount after 6 years. We're going to get 41,635.09. So that is it, guys. With this concept, we are done. Compound interest direct, as you can see. On question number 3, which is on integers, 11 marks on this one. We are asked to simplify. So this is also direct. 3.1, we are given 2a into minus 3a minus 5a, like this. All right. So there is a product, guys, a and a. Yes, it's integers, but also laws of exponents must be used. So a times a is what? A squared. So it's going to be 2 times negative 3, which is negative 6a squared. Minus and a minus, remember, a negative to a negative, a plus. So that was going to give us a plus 5a. Can we simplify this? No, these are unlike terms because of the difference on the exponents. Yes, there is a there, but they are of different exponents. So we refer these ones as what? Unlike terms, because of that. These are what? Unlike terms. So we are done. There's nothing that we're going to do there. All right. So that was the first part. 3.2. On 3.2, we are given again another part on our integers there. Also use the laws of exponents there. So this was going to be negative 20d to the exponent of 5 over 4d to the exponent of 2. So if we are to consider here, guys, we can simply divide the numbers separately. Negative 20 and what? And 4. That was going to be negative 5. Then here we can simply apply our laws of exponents, guys. Dividing same bases, we subtract our exponents. So meaning to say that was going to be minus 5d to the exponent of what? Of 3. All right. That's like that. So if we are to consider another part, let's check 3.3. So this one is direct, just like that, guys. This one is just direct like that. Here we are given 2a into 4b to the exponent of 2 plus, then we have got 3b into minus 2ab like this. Everything over what? Everything over 2ab squared. All right, let us just see properly here. We can see that it's very true. There's a bracket here. So what can we do? Expand. So the 2a was going to multiply inside of the bracket. So we're going to multiply the number to the number. 2 times 4, which is 8. So as we can see, a and b, these ones, we just write them as they are. They are not affected. So a with as it is, b as it is, b squared. Same thing here, but you must consider that there's a sign, a plus and a minus. So a plus and a minus was going to give us a minus. Then we multiply just like the previous case, 3 times 2, which is 6, a. But if you check, there is b and b. So b times b was going to give us what? B squared. All right. Everything over what? Over 2ab squared. Remember, like terms, it is because we have same term, same exponent, same presentation, guys. As we can see here, a b squared, a b squared, same presentation. These are like terms. So we can even subtract here 8 minus 6. We can subtract what? the coefficient of these like terms, the numbers, which are these ones, 8 and what? 6. So you can subtract 8 minus 6, which is what? Which is 2. The rest remain as it is, which is the b squared over what? Over 2ab squared, like this. So this is what you're going to have. And as you can see, guys, it is just like you're given x over x. Guys, let us go back to our numbers. 2 over 2. What do you get? A 1. What about x over x? A 1. What about this one? It is exactly the same. This one can cancel. This one can cancel. This one can cancel. So it's just like we have got 1 over 1, which is what? Which is a 1. If you are dividing the same term, it cancels to give us a 1. X over x, y over y. That's the 1. Okay? So that was it on this question. Make sure that you go through the revisions, but we talked about these guys on your introductions. Make sure you go through each topic separately. On 3.4, using the same approach, minus 3x squared into what? Minus 2y, by there is an exponent of 3 affecting only this bracket. Only that part. So what does it mean? It means everything in this bracket must be raised to the exponent of 3. We must see a negative being raised to the exponent of 3. We must see 2 being raised to the exponent of 3. Y being every term. Every term. So this one, let's rewrite as it is. Minus 3x squared. So we're going to multiply whatever that we'll get from here. So minus, when raised to an odd number, to an odd exponent, it remains what? As a negative. So that's a negative, this one. Then 2 to the exponent of 3. 2 to the exponent of 3 is what? 8. 2 times 2 times 2, 3 times. That's 8. Y is also raised to the exponent of 3. So that's y to the exponent of 3. Just like that. So make sure you apply that concept. And as we can see, it's a multiplication. So remember, negative times negative, that's a positive. So we can just ignore that positive. So 3 times 8, that is 24. The x squared and y to the exponent of 3 as it is cannot be combined. It will just remain as it is. In this case, we just combine as it is, like that. All right. So this is what you're going to have. And on another part here, simplify again. 3.5, we have got negative the cube root of 64 minus the square root of 25. So guys, you just need to know what is the cube root of 64. But in case you do not know, then use your calculator. Let's go back to the normal mode. All right, what am I doing here? Normal mode, number 8, then press 2. So you can just use your calculator. The cube root, shift. Here it is the cube root of what? 64, which is what? Which is 4. But there is a negative there. So it's minus the cube root of 64, which is what? Which is 4. Minus this one, the square root of what? Of 25, which is 5. So we have minus 4, minus 9. Remember, guys, when you are given like this, you add these. So you get a 9, then you use that common sign on your answer. Or use your calculator. Why you having calculator and not use it? Use it, guys, okay? It's exam. Can use it. It's not a problem at all. On question number 4, part of your exponents, simplify 2. All right, that's 4.11. Here we are given 3 into 2y to the exponent of 3 squared. So remember the previous case here where we've got the exponent of 3, which affected everything. It is the same thing with 2. So you're going to raise everything, but take note the 3 is outside of what? Of the bracket. So it's 2 to the exponent of 2, which is going to be 4. y also must be raised to the exponent of 2. But take note, it's what? Y to the exponent of 3 to the exponent of 2. So an exponent and exponent, what? How do you simplify? You multiply. So 3 times 2, that's 6. So that is what you're going to have there. 3 times 4, which is 12, y to the exponent of what? Of 6. Just like that. So you are done. You are done. 4.12, same again, apply your laws there. So guys, you can simply cancel 3 into 6. That's a 2 here. A to the exponent of 3. This is a squared. So you are dividing, you subtract your exponents. So that's a to the exponent of 1, which is what? Which is a. The part of b, this is 1 here. So you're going to subtract 5 minus 1. B to the exponent of 5 minus 1, which is b to the exponent of 4. From our laws of exponents, dividing same bases, subtract what? Exponents. So this is what you're going to have at the end. And we are done. All right, let's consider 4.2, 2 times 5, but everything is raised to the exponent of 2. So what is 2 times 5? 2 times 5, that is 10. To the exponent of 2, 10 times 10, 100. 3 to the exponent of 4 divided by 3 to the exponent of 2, same basis here. Look, same basis. So the same concept, just like the previous case. So we are simply going to divide our exponents there. 3 to the exponent of 4 minus what? Minus a 2. You are going to divide, you're going to subtract the exponents. So that's 3 to the exponent of 4 minus 2, which is 2. 3 to the exponent of 2, 3 times 3. 3 times 3, which is going to give us what? A 9. So that is what you're going to have them. Just like that, just like that, just like that. So 4.23, we have 4.23, 2 to the exponent of 3 plus 2 to the exponent of minus 3. So guys, we can simply evaluate 2 to the exponent of 3. 2 times 2 times 3 times, that's 8. Plus 2 to the exponent of minus 3. Remember, when you're given a negative, it simply means 1 over x to the exponent of negative n, 1 over x to the exponent of n. So it simply means 1 over 2 to the exponent of 3, which is 1 over 8. Remember, we said 2 to the exponent of 3 is 8, so it's 1 over 8. A whole number to a fraction, when you're adding, you simply combine them together like this. So it's 8 and 1 over 8. You're done. This is a whole number, guys. This is a fraction. So you simply combine together. All right, moving on to another part we are given. 4.24 to simplify again. That's 4.24. 2 plus 3 to the exponent of negative 2. Remember, a negative, like just like the previous case, 1 over 2 plus 3 to the exponent of what? Of 2. So this is what we have. And just like the previous case, we can add this case. 2 plus 3, that is 5, raised to the exponent of 2. So that's 1 over what? 5 squared, which is what? 25. 1 over 5 squared. It means 1 over 5 times 5. 5 times 5, which is what? 25. Just like that. You are done. Then another question. Question number 5 was on the numeric and geometric patterns. I just worked this one recently. Unfortunately, we did not manage to do as many questions, like do more revisions, question papers. We're going to also find time to work on that one. But as an introduction, I talked about this. So given this, we are asked to study on 5.1. Study the pattern made of matchsticks and answer the questions that follow. So we have got the first figure. How many matchsticks are there? That is 1, 2, 3. There are 3 of them. Here, the same thing. we have got 1, 2, 3. Then there was another one which was added here, another matchstick, and this other matchstick. So we can see now the 1, 2, 3, 4, 5. So it's like here there were 3. Here there are now 5. Here it's 1, 2, 3, 4, 5, 6, 7. There are 7 matchsticks that we have there. All right. So the question was 5.11, draw pattern number 4. Pattern number 4, we're supposed to draw like how it was supposed to be. So as we can see, guys, pattern number 1, there were 3 matchsticks. Pattern number 2, there are 5. Pattern number 3, there are 7. As you can see, there's a difference of 2, 2 from this one, 2. From this one, 2. There's a difference of 2. So we are simply adding 2 sticks here. From this one, there are 3. To get a 5, we added 2. From 5 to get a 7, we added a 2. So meaning to say here, from this 7 to another one, we are going to add a 2. So meaning to say there are supposed to be 9 matchsticks that we are supposed to have here. They're supposed to be 9. But we simply continue from this one as it was here. So here it was like this. I'm just gonna draw, guys, the triangle like this one. All right, I just hope you see it. All right, so this one, we're just gonna continue. It was like this, this one. All right, so this one and this one, then there's this one, a triangle like this, which was formed like this. So this is this one, the 3 that we had, the position 3, where there are 7. So we are going to add 2 matchstick balls from each to another one. We are adding 2. So we're going to draw another one. You can just draw it like this to complete a figure. So it's going to be like this. All right. So this was how we're going to have our figure 4. All right. Just like this one. Remember when it was just a triangle like this, you extended that triangle, this one, this piece. So it is this one that we extended. We are just adding 2 sticks, this one and this one. All right. So that was it on this one. For 5.12, describe the pattern in your own words. Guys, I have already described this one to say here there are 3. We are adding 2. Like we started with what? 3. Then from each, we are adding what? 2, 2, 2, 2, and so on. So here we are simply adding, we simply have to add 2 sticks to the previous pattern. Like from this one, we add 2 to get 5, 2 to get 7, 2 to get a 9. So that is in words. Add 2 sticks. Add 2 sticks to the previous. Add 2 sticks to the previous pattern. The pattern that you have previously, you must just add what? 2 sticks to that one to get the one that is following. Just like that, you are done. All right, so this is what you're given. So those 2 sticks, it is just like the difference. There's a difference of 2. So this one, there's a constant difference in actual sense. So after that, they want you to write down the general term of the sequence in the form Tn, this one. All right, remember your general sequence in the form Tn. So guys, we can see that there is already a difference there. There is already a difference of what? Of 2. What you are adding 2 is the constant difference. We can already see that. There's a constant difference there. So if there's a constant difference, how do you determine the general term? For a constant difference, I said it is easier that you take Tn is equal to the constant difference times n plus what? What must be added to give us the term in position. So already this one, we have it. It is a 2, our constant difference. What about this one? What must be added? You can just use the first term to find what must be added, this one. The first term here, first position, right? Position 1 it means T1 is equal to what? 3. How many sticks? There are 3. Position 1. Position, remember, any position. So position 1 is what? Is 3. So 3 is equal to 2 into n. Any, our position. Position 1. What is that? Which is supposed to be added to give us that term in position? Which one? This one. Let's find it. 2 times 1, that's 2. So that's 2 plus what must be added? Take this to the other side. That was going to be a minus there. 3 minus 2, which is what? 1. So what is that part which is supposed to be added is what? Is a 1. So this is the one that we need here. The one that must be added here is what? Is a 1. So therefore, our Tn is what? 2n plus what? 2n plus 1. Just like that, okay? You're done. Just like that. So this is the general term that you're going to use to find anything, any part. Like this one on 5.14, where they're saying, without drawing, do not draw them, but determine what? The number of matchsticks needed to build the 17th pattern. Without, you're not supposed to draw. So how can we find? We are simply given the position 17. What is the term corresponding to that position 17? When n is what? Is 17. This is the question. This is the question. Find T17. When n is 17, just substitute in place of what? N. 2 times 17 plus 1. What is 2 times 17? We simplify that one. That's going to be 34 plus 1, which is what? Which is 35. Just like that. You're done. Just like that. So 5.2 was another question different from 5.1. Like in terms of the question, you are using a different general rule of which you are already given. They are saying the rule for finding the output values on the table below is, you're already given on how to find the output. The rule is already given. They are not saying calculate it. They already gave you minus half of n plus what? Plus 3. With this rule, complete the table and write down the missing values. Remember, n is just like a position. N we are given. When n is 2, when n is this, find what? Tn. So this is what we are given. When n is 2, just put there 2 in place of n. So it means when n is 2, we're going to have minus half. We substitute in place of n, we put minus 2 plus what? Plus 3. Guys, this one you can just even use your calculator. It's just to substitute there. Nothing much there. Minus half of what? Minus 1 over 2. All right. It's because I changed the setup there. No problem. But that was, just use a calculator there. It was going to give you a positive 1 plus 3, which is what? Which is 4. Anyways, that was our A there. The first part representing our A is 4. So it means A is equal to 4. The same thing, guys, if you move on to the other part, what are we given on the other part? Our n this time is what? Is 0. In place of n there, you put a 0 this time. This is what we have. So you use your calculator again. Minus half times 0, that's a 0 plus 3. 0 plus 3, that's what? That's a 3. So it means B is equal to 3. This one is 3. The same thing for this C that we are given there. In place of that n, what are we going to substitute? Because we are given that value there, that n is what? Is 4. So you put there 4. Minus half times 4, that's minus 2 plus 3, minus 2 plus 3, which is 1. So this was going to give us what? Was going to give us a 1 on this 4. That's a 1. You move on to the D. All right, so on D, take note. We are not given there. We are given Tn. So let's leave this one for now. let's just do this one at the end where we are substituting because we are given n there. N is the one that we are given at the end there. So when n is 8, we put 8 there. So you're going to put n in place of 8. So minus half of 8 was going to give us minus 4 plus 3, which is minus 1. So guys, I want you to just use your calculator if you can. That was going to be best. All right, so let's find D. So as we can see on that part of D, it is actually different because we are not given n. The n is the one that we are to calculate. We are given Tn to say Tn is what? Is 0. We are given this one to say Tn is 0. What is the value of n? D represents what? N. So you're supposed to calculate to find n. So it's an equation. 0 is equal to minus half n plus 3. Where are you now? Back to equations. You're supposed to solve for n this time. So it's either I'm going to take this to the other side so that it becomes a positive. Half of n is equal to what? To 3. So how can I find n, guys? This is same as what? Over 1. So we can cross multiply. So that's 1 times 1n, which is n is equal to 2 times 3, which is what? Which is 6. So n is equal to 6. And n is representing what? D. And on that question of ours, the number of terms, n is representing what? D. So it means our D was going to be what? A 6. You solve as an equation, guys. Equations, we have been solving equations from our grade 8 mathematics, remember. So that part, we are supposed to put it in mind and keep that in consideration that it can be used in your simplification. So these are the typical questions that you might have in your March test. You might have something familiar to this. Revise as many questions as you can. So that's it, guys. Till we meet again.